Alright, so now I agree two sets Venn diagrams. So how do they look like? A two set Venn diagram is just like a one set Venn diagram, just that it has two sets. So I draw my box, I'm my first set, and I'm my second set. The first set is called A, second set is called B. This is what it is going to look like. So here we have the introduction of the new part. This part, intersection. A intersection B. So the difference we just get at this point. Okay, let's start some questions here. Wait, full set. So we have an example. So as you already know, this is the part that shows only A, the part that shows only B, and this is the part that shows A and B. And above it we have the part which shows neither A nor B, which is zeta minus A and B. It shows elements which are not in A and not in B, but are in the universal set. So an example we have antizeta is equal to 1 through 10. Alright, we have zeta from 1 to 10. We have A equal to 2 3 equal 7. And we have B equal to 1 2 3 4. So if you are asked to represent this in a Venn diagram, what are we going to do? So instead of representing this efficiently in the Venn diagram to minimize errors, you first have to look for the intersections, the bigger intersections. In this case, you have to look firstly for A intersection B. What is the intersection B? The intersection B is part. Intersection B means values are in A, elements are in A that are also found in B. So you have here 2 and you have 2. So I can write it. I can write 2. Here I have 3. Here do I have 3? Yes. I have 3. I write it. Here I have 5. Do I have 5 here? No. Here I have 7. Do I have 7 here? No. So I found my A intersection B, so I already know what is in the middle here. Alright. The next I'll find A only. It's like A only. So one is A only. A only is equal to, if you check this formula here, n of A only is equal to n of A minus n of A minus B. So to have A only, it is A minus A intersection B. It is A minus A intersection B. See, n of A only is equal to n of A minus n of A intersection B. It means A only is equal to A minus A intersection B. So I can say it's equal to A minus A intersection B. What is that meant to be equal to? This A minus B intersection B means in all of these values we remove this value here. So we have our A. Inside this A, we remove A intersection B, we remove 2 and 3. So this is A here. A is 2, 3, 5, 7. Inside the A, we removed these two values. What are the two values? 2 and 3. So it's inside this A, we remove 2 and 3. We're left with 5, 7. So our set is 5, 7. 5, 7 is A only. If you check well, 5, 7 is found here in A. It is not found in B. And it is not also found in A intersection B. It means it is actually really found in A only. And of course, it's also found in our universal set, it must be found there. So you same for B only. B only will be equal to B minus A intersection B. Among my data say it's supposed to be B minus B intersection 3, but that's quite the same thing. A intersection B is the same like B intersection A. So this B intersection A means inside B we remove this B minus A intersection B. It means inside B we remove A intersection B from it. We remove these two, its elements from here. Inside this B we have 1, 2, 3, 4. If we remove the A intersection B from it, what will we be left with? So here, from here I remove 2, and I remove 3. I'll be left with only 1 and 4. So I write 1 and 4, then is my B only. So when I found the intersection, I find now, after finishing to find the intersection, I find this part, then this part. Then I find what to say. So someone is in the middle first, then the only is 10 years outside. Even in a lot of the presets, we found what is in the middle first, then what is in there. Other sub middles, then the only is, then what is outside. So we already have what is here, we already have what is here and here, then we're looking for what is here, outside. So, how you call it? Neither. Let's just call it neither. It's equal to what? Neither is equal to antizeta minus A and B. Is equal to antizeta minus A and B. What does this neither mean? Neither we are looking for this part. All of that is not in A and B. So epsilon is zeta minus A and B. So we are looking for numbers which are not found in A nor in B, but which are found in zeta. So we are looking for numbers which are not found here, and which are not found here also, but which are found here. So what was that equal to? What is A? And B. Is this 2? Yeah, 2, 3, 5, 7, and then 1, 2, 3, 4. So A and B will be 2, 3, 5, 7. Or let me just put it in 2, 3, 4. Okay, there is 1, 2, 1, 2, 3, 4, 5, 7. This is A and B. And we want zeta minus A and B. So we look at this zeta here and we remove everything that is in A and B. If you check well, A and B is actually A plus B minus A intersection. So if I add A equals B, I'm going to have 2, 3, 5, 7 and 1, 2, 3, 4. So I'm going to have 1, 2, 3, 2, 3 again, 4, 5, 7. Because 2, 3 are base here, 2, 3 also are base here. Let's say the formula says NA plus NB minus NAME. What is my NAME? 2, 3. So one of the 2, 3s to go. I'll just put 5, 7, 1, 2, 3, 4. Like 5, 7, 1, 2, 3, 4. Just like that. So that's A and B. So now we're looking for neither. Neither is epsilon. Is zeta minus A and B. But epsilon is zeta. So I look at here and I remove all of the values that are here. Is 1 here? Yes, I remove it. Is 2 here? Yes, I remove it. Is 3 here? Yes, I remove it. Is 4 here? Yes, I remove it. Is 5 here? Yes, I remove it. Is 7 here? Yes, I remove it. All I be left 3. 6, 8, 9, and 10. So the one that will be neither in A nor in B. The elements are 6, 8, 9, and 10. So now I add them. And then because you have created A intersection B, this video part, then we have A only. With part here is left part. Then we have B only, the right part. And then there are neither A nor B to this part outside of it. So how I'm going to represent it? Let's try representing it on a Venn diagram. So let's draw my square or my rectangle, whatever. My anti-zeta. And I come my two sets. How two sets here? A and B. A, B, those are my two sets. So A intersection B, I have 2 and 3. So right near my 2 and my 3. I'm done here. A only, I have 5 and 7. So in A only, I'll write here my 5 and my 7. B only, I have 1 and 4. B only is this part here. I write my 1 and my 4. Now neither A nor B means this not here, not here, not here. It is outside. I have 6, 8, 9, 10. 6 in the variety anywhere than 9, 10. I am done. I got the Larry. When you write, you make sure that all of the elements that you have all of the sets would be in the Venn diagram. So there should not be any elements left behind. So yeah, that is it for the first example. So let's do another example. Alright, this is another example. We have example 2. Our anti-zeta as letters A to G. Letters A to J. So what is letters A to J? This is the descriptive form. Let's put it in the listing form. We use these letters A, B, C, D, E, F, G, H, I, J. And you accept A, equal to A, E, I. I, and we cell B equal to A, B, C, Z, D. A, B, C, D, E. Alright, so you're getting this data and you're asked to represent it in a Venn diagram. So what are we going to do? Like what we did before, we are going to first do for the intersections. So we're going to look for this part here first. Always look for the intersection, the highest intersection. Now when we go to three-set Venn diagrams, you understand why I say higher intersection. Because in the three-set Venn diagram, you're going to see A intersection B, intersection C, because there will be 3 sets. So you should look for this higher intersection first, then you look for this E intersection B, then E intersection C, then E intersection C. Then you can find the A only and the B only, and then the either. So in this our case, the highest intersection is A intersection B. Just find an intersection B first. So what is A intersection B? Everything that is in A, that is also in B, I write it here. So what is it? A, A. A is in A. The same A in B, yes, I write it. E, it is here. Is there E here? Yes, I write it. It is here. Is there I there? No. I remove my comma, close my bracket because this already finished. If you look for one set, if you look for the errors in one set and they finish, you can stop. Because you might say, okay, let me come here and check in, come here and check in. If you are ready to check, you want to say like A, is there A here? Yes. E is there A here? Yes. I is there I here? No. If you finish with this set, don't need to check B with this set. Say A is there A here? Yes. B is there B here? C is there C here? No. Do one set. If it finishes, then those are the only elements in the intersection B. So when you're doing A intersection B, you're doing your intersections. Now find your A only and your B only. So what is A only? A only is elements that in only A, not found in B. Which element is found in A that is not found in B? If you look with your eyes, you see that there's I in this A and the I is not in this B. So I can just write here I. But in the areas of too much, or if I don't know how to do it logically, you might either use your logical thinking, or use a formula. If you don't know how to use your logical thinking and see that A is here and not here, you can see with the formula, number of A only is equals to number of A minus number of A intersection B. So if I want A only, how will I do it? I'll do A minus A intersection D. So what is A minus A intersection B? Let's try and do A minus A intersection B. What is A only? A in a subscript O reads only, I'll put it as only. It's equal to A minus A intersection B. What is A? This is A here minus A intersection B is what? AE. So inside this A, I remove A intersection B. So I have A as AEI. Inside it, I remove A and A. So from this AEI, I remove A and A, I remove this and this. I'll be left with I. So I can just write my I with. You see, using the formula, I have the same answer as using logical thinking. You see, when you use logical thinking, it would be way faster. But when you use a formula, it will be less difficult to make errors because the formula is constant, it will always be correct. When you use logical thinking, you should make sure that the way you're thinking is the correct way. So when they say A only, it means values of A which are not found in B. If you have sets A, B, and C, and they say A only, it means values of A which are not found in B and C. In this case, one is A that is not found in B. I. So my A only is I. I do same for B only. What is my B only going to be? Using my logical thinking, I look for values of B which are not common in K. Don't check with the values in zeta. If you check with values in zeta, they will always be found. You will see that all of the values in B are found in zeta. All of the values of A are found in zeta, and it is normal. It must be found in zeta. All of their values here must be found in zeta. So you don't compare with zeta, you compare it with the second set or with the two other sets if you have 3 sets. In this case, if you have just 2 sets. So you have B on A. What is B on A? B on A are the values of B which are not found in A. So the values of B not found in A. You have A. A is found in A, okay. B is not found in A. I can find my B. C is not found in A. I can find my C. D is not found in A. I can find my D. E is found in A. I don't write it. So I can see that my values of B only are B, C, and D. Because B, C, and D are found in B, but not in A. So if I don't know how to take it like this, I can use my formula. I can still use my normal formula. B only will be equal to B minus A intersection B, or B intersection A if you wonder, it is the same thing. So on B only, it says B minus A intersection B. So if you look at D, and from that D you remove A intersection. Remember, minus means removing. So from this B, I remove A intersection B. What is A intersection B? A and E. So from this B, I remove A and E. I'll be left with what? If I'm removing A and E from this B, I'll be left in B with B, C, G. I have B, C, and then you see, whether you use your vertical thinking or you use the formula method, your answer will be correct. Remember, this one in the end here, you might be confused that why am I using B and A intersection B without the ends, whereas you have foot end. This one in the end here shows the number of elements in B, not the actual elements of B. But here we want the actual elements of B, not the number of elements. You see, because here they've given us actual elements, they've given us A, B, C, D, E, F. They are distinct elements. So we want which of those distinct elements we found in this B. We don't want the number of elements, we want just the elements. That's why we remove the n. So you can put n of A on it if you're looking for the number of elements. Okay. So that's going to be it for B only then. So you already have A that's from me, A only and B only. You'll be left with this here, which is neither A nor B. So neither A or B will be equal to antizeta minus A union B. This is the formula method, but if you're looking for neither, then you check. If you don't really, they are logical JT. You are going to check here which values are in these two. Which value is in this zeta is not found in these two. In these two, you have A, you have B, you have C, you have D, you have E, and you have I. So is there any other letter here which is not found in both of these two? Using my logical thinking, we look at A. Is A found here? Yes. I'm gonna write B. Is B found here? Yes, I have a B. C. Is C found here? No. Yes, I have a C. D. Is D found here? No. Yes, so I don't write it. E. Is E found here? Yes, I don't write it. H. Is F found here? No. No. You see, H is not found in either A nor B. So neither of them will be equal to, they're going to have F, then I continue G. There's no G in either A or B, but I write also G. I continue H. There's no H in either A or B, I write also H. I. There is I here, so I don't write it. J. There's no J either in A nor B, so I write in J. So, yes, you can do it like that, or you can use the formula method, because the formula says it is anti-zeta minus A union B. So it says zeta minus A union B. The A union B is what? A union B is A plus B minus intersection B. So the A plus B, I write my A and my B. B equals to zeta minus A union B. A union B is A. Okay, and write this, zeta minus A. Yep, K, E, I, and B, and A, B, C, D, E. A, B, C, D, E. This is A union B. I put all the values of A and all the values of B here. That is NA, that is A plus B. So I should do minus A intersection B. So this is minus. Minus means I'm removing. What is A intersection B? A and P. So it means from here, when I put everything like this, I should remove A and P. So I remove YA and I remove one E. So I'm left with E, I, A, B, C, D. Make sure that when you remove one, it must still be there. You're removing it because it's there twice. It appears twice. It should not appear twice. So when you're removing A and D, make sure that they stay A and D once there. Or when you remove any intersection, you make sure that you accept that you're removing there's still one intersection. So now we can determine this. What is this? A and B. This is our A and B. So I'll do all of the elements here minus this one. So minus B is we remove. So we look at the elements here and we look at here. If we look at the elements here and we remove all the elements that are here. So we look at the elements here. We remove E, Z, E, S. So here I remove it. Okay. Let me just cancel it. I cancel I. A I cancel A. B I remove B. C I remove C. D I remove D. What am I left with? I'm left with F, G, H, and G. F, G, H, and J. F, G, H, J. You see that it is the same answer using your logical thinking or using a formula. You have the same answer. So if you find difficulties using thinking to find the answer and still rely on the formula and never fail, given you know how to use the formula and normally never fail. So you have your A position B, you have A only, you have B only, and you have neither. So what else do we want? What do we want is to draw an event like this is A, this is B, and this is zeta. So we fill the Venn diagram. Now A intersection B is equal to A and E. Now A and E, A intersection B. My A only is I. Alright, I will. My D only is B, C, and Z. Alright, B, C. And my neither is F, G, H, J. Phoretic. F, G, H, and J. And that is all for that Venn diagram. So the best thing you have to do is first find your intersection. The highest intersection. In this case, there's just one intersection. In the next 1 hour, we're going to do is we are going to see that there are more and more intersections. You find the highest intersection. Then you find A only, B only. Then you find neither. Values are not A and not B. So when I don't think this in the Venn diagram, they can ask you what is N of A. They can ask you what's N of A. Okay, what is N of A is A, E, and R. N of M is the number of elements found in the string. So it's N of A only. It's a N of A only is 1 because each element is found in A only. Alright, first one. So they ask you what is N of A prime. What is N of A prime? A prime is just every element which is not found in A. So every element which is not A and I. So you check all the elements here except from A and I. We count them. You have 1, 2, 3, 4, 5, 6, 7. There are 7 elements apart from A and I. If you count all of them, in total there are 10. Then if you remove Q elements from it, they are going to have 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So your answer is normally 7. We can also ask you B prime, where you are going to have 5. We can also ask you A union B. So number, we know what is the number of elements in A union B. What is the number of elements in A union BP? I'm going to use this formula. A plus B minus A intersection B. I will just use the formula. The using this formula is the intersection is repeating. They're removing an intersection. If in A you have 2 and in B you also have 2, you use this K in order to remove one of the 2. So that's the use of it. Because you cannot have an element appearing 2 times in the set, the same element appearing 2 times in the set. So if you are asked to count the number of elements in A union B, how many elements are found in A and B total? So in A,